Hello, friends. Welcome to another session for Maths with me. So, what we cover here, we are primarily covering the CAT and non-CAT MBA entrance exams topic that are relevant for the quant section that comes in any entrance exam in India. Primarily, we are focusing in CAT, and subsequently, we will focus on other entrance exams and learn what are the differences the other exams has. Those are minute differences, not much, but if you prepare for CAT, like we always mention, you'll be able to cover most of the quant sections that are coming in CAT. So with that, so we are currently in part of doing the algebra section, and if you see the previous session, we talk about progression, which covers APE and GP. And this is a very important topic in terms of your algebra section of CAT. So after arithmetic, algebra has the most weightage in terms of your CAT exam. And like we always do, we cover a 1+2 model where in the first session we cover the fundamentals of progression. I'll put the link of that video in the description box. Then we did a progression of level 1 or level 2 kind of a problem in progression where we strengthen our understanding of fundamentals on progression. I'll put that video also in the link. But the idea is, if you are this is your first video on progression, I would suggest you go through the previous two videos first so that you get an understanding of the concept and the formulas and how to apply. This session is typically a mid complex to a little advanced level problems. We will solve some level 2 problems, but we'll also solve some level 3 problems in this. And this is going to be the last session progression. So like we always do, fundamental level first problem session, clearing the fundamentals, and second problem session, a little advanced ones. So with that, let's get started. Uh, yeah, so let's start it. So it says, in a GP with even number of terms, ratio of sum of odd terms to sum of total terms is 5. Right? So if it is a GP, now how we normally consider a GP is A plus AR plus AR square plus AR cube. So we know in a GP, the necessary condition is my common ratio between two subsequent terms should be same. So here my common ratio is R. So AR by A is R, AR square by AR is also R. So say the third and second term common ratio is R, fourth and third term common ratio is also R. So the common ratio we have across all the subsequent term is only R. So that's the assumption. That's the mandatory condition for a GP. And we have assumed the series in such a way that the ratio between two subsequent terms always remains same. So these are even number of terms, ratio of sum of odd terms to sum of total number of terms, right? In a, yeah. So what we have to do? So so can I say this is my, if I talk about the odd term, so this is my odd term, this is my odd term, AR to the power 4 will be my odd term. Even term is AR squared. These are my uh, even terms. So ratio of odd terms, so sum of odd divided by sum of even. That's what they are looking for. So let's say sum of odd means I can say A plus AR square plus AR cube. So let's say to the power AR to the power N, right? Or I'll say AR to the power N, because these are even terms. So let's say there are N number of terms. So till N, so since, see this in a way. So if you have even number of terms, what will be your last term? So if there are even number of terms, this is first term, second term, third term, fourth term. So these are four terms. Out of that, the last term will be the even number terms, because the fourth term will be an even number term. So AR to the power n minus 1, we can say. For odd, because since there are even number of items in the GP series, your n is even, your the last term will be a even number term. So you have to calculate the odd number of terms, you have to go one before that. Similarly here, it will start from AR. So this is AR to the power 4, AR cube, AR to the power 5 till AR to the power n. So that's what we have to do. Now, if I take R common from the bottom, so the top one will be AR square, AR to the power 4, AR to the power n minus 1. From the bottom, if I take R common, it will become A plus AR square, AR to the power 4, AR to the power n minus 1. So I can see my numerator and denominator within bracket both are same. So I can say this is same as 1 by R. So this ratio, they said 1:5. That means my R is equal to 5. Sum of odd and sum of even, they said 1:5. So that's what we did. My R is equal to 5. Simple, straightforward. Just understand how to write. So the even number of terms, that means the total number of term will be even. That means the last term has to be an even number term. So if you have 4 terms, the 4th term is the last term. If you have 10 terms, the 10th term is the last term. So the last term will be the even number term. So when you are doing a sum of only odd numbers, you have to go till n minus 1, because nth term will be a even number term. Okay, so that's the only understanding here. Rest is directly straightforward. You put the formula, take R common and you calculate. Okay. Let's move to the next one. So it says, so these are infinite number of terms. So if you see this series, there is a consistency in the series. So the second term of the previous second, so if you see the denominator 5 into 7, so the second value of the denominator here is the same value of the subsequent terms first denominator. So 7 here and 7 here will be same, 9 here and 9 here will be same. So there is a continuation, or we can say there is a, these are the series with a continuation. So 1 by 5 into 7, 1 by 7 into 9, 1 by 9 into 11, and these are infinite. Whenever you have such kind of a problem, always try to uh, break your denominator into single terms. So there are 2 terms in the denominator, 5 and 7. So to break that, uh, I have to have something in the numerator, right? So the idea is always whatever is the gap. Also, the second thing that you can see is the gap. So here the gap is 2. In the first term, the gap is 2. 5 and 7, the gap is 2. 7 and 9, the gap is 2. 9 and 11, the gap is 2. So the gaps are same and there is a continuation. So these are 2 indications for this kind of problem. So I'll just write gaps same and continuation. So if you see these 2 hints, you should be able to identify how to approach this problem. So if these 2 are same, then obviously you have to write the gap on the numerator. So, and how will you write that? So if I write 2 by 5 into 7 plus 2 by 7 into 9 plus 2 by 9 into 11 and so on. But obviously I had 1 in the numerator. If I have to write 2, I have to whole divided by 1 by 2, right? So I'm dividing by 2, I'm multiplying by 2, numerator and denominator, for every term. So the 2 in the numerator can be written as 7 minus 5 in first case. Similarly, can be written as 9 minus 7 in second case. Similarly, written as 11 minus 9 in third case, and so on. Now, if I do this, this will become 7 by 5 into 7. So that means 1 by 5. 5 by 5 into 7, that means 1 by 7. 9 by 7 into 9, so that means 1 by 7. Minus 7 by 7 into 9, so 1 by 9. Previously, then it will become 1 by 9, minus 1 by 11, so on. So you will see 1 by 7, 1 by 7, 1 by 9, 1 by 9. It will continuously get cancelled. The last one will be infinite. And we know 1 by infinite is almost equal to 0. So the last one will be 1 by infinite. 1 by infinite is always 0. So my value will be 1 by 2. The first term only, that is 1 by 5. If 1 by 10 is my answer. Okay, so I hope this is clear. How we are trying to solve. So the gaps are same and there is a continuation on the terms. You should be able to divide and multiply the fraction with the gap and then rewrite the gap as the values in the denominator. Okay, so that's the approach for this kind of a problem. Again, repeating two very important things. If we are trying to solve around 8-9 problems in this session, your idea is to solve at least 3x or 25-26 problems of this kind when you are trying at home. So the idea here is you will try that many amount of problems. So in progression 1 and progression 2 together, if you have solved 20 problems, the expectation is you will solve at least 60 problems at home so that you can completely understand the topic. And if you understand the topic, you will be able to do much more justice when you get a problem in a mock or in any exam. So do at least 60 problems at home. If you feel stuck, if you need any help, you can drop a note or you can drop me a mail with the mail ID given in the description box, should be able to help you. But the idea is try at least 3x problems of what we have done here. And also, if you have seen the progression problems earlier, or if you have some context, and the idea is if you're coming to this problem session 2 with some context of progression before, you can go through the videos I have put in the description box. But if you're coming to this session, don't start seeing the solution right away. See the problem, pause the video, try to solve it at your end for 2 minutes. See if you get the approach. You may not have to solve it entirely, or you can actually, but then come back and see whether you have what you have done is right or where you have stuck and how we approach the problem. Then you have some understanding or some mind muscle connection that is getting established on how to approach a problem rather than seeing a solution right away. So these problems has a solution. Will walk you through the approach. I will walk you through how to solve this kind of problem. But first, you need to think from your side how, without seeing the solution, how you would have approached the problem. So spend that couple of minutes time before you start, continue the video with the solution. Okay. Moving on, the next problem, 1 plus 2x plus 3x squared plus 4x cubed. So 1 plus 2x plus 3x squared plus 4x cubed till infinite. So you have to find the sum of it. Right? You have to find the value of s. S is the sum. Now, if you see carefully, this is also a pattern. What is the pattern? The coefficients 1, 2, 3, 4, these are in AP. And the variables x, x squared, x cubed, these are in GP. So this is called a AGP, or arithmetic geometric progression, right? So this type of problem is called AGP, or arithmetic geometric progression. The first part here is you need to make it either an AP or an GP. How you do that? So the standard approach, you multiply s with x. So what will you get? Your first term become x, second term become 2x squared, third term become 3x cubed plus 4x to the power 4 till infinite. Now, since there is an infinite term, now how will you write it? So this is very important. Understand. S is 1 plus 2x plus 3x squared plus 4x cubed plus infinite. Sx, or after multiplying s with x, since these are infinite terms, and this is only can be doable in infinite term, what I'm trying to do now. Since there are infinite term, I'll start writing the Sx value leaving the first place. So my first Sx is here, x plus 2x square plus 3x cubed is infinite. Since there are infinite term, I can consider Sx writing one step after, or first I can ignore the first place and put Sx. Think of there are 5 items in both the buckets. You have put 5 items here, and then you have put another 5 items here, leaving the first item of the first set. So you don't necessarily need to put first item of the second series right below the first item of the first series. You can put the second first item of the second series, which is x, right below the second item of the first series. So your entire series is shifted by 1 unit, but that is insignificant because there are infinite number of series, infinite number of terms. This is again only doable in the infinite number of terms. If you have to do without infinite number of terms, we'll see how to do that, but that will have, you need to know the last term and how that will react at the end. But as of now, since this is an infinite term, we don't need to do it. So now if we do a subtraction, so if we do a subtraction, so this is minus, 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 right? Finally, you will get s minus sx is equal to 1 plus x plus x square plus x cubed till infinite. So s, if you take common, this is 1 minus x. Since this is an infinite GP, 1 plus x square plus x cubed, these are infinite GP, so 1 by 1 minus x. So infinite GP, what we know, sum of infinite GP is 1 by 1 minus r. So in this series, you see r, or common ratio, is x. So that's why we got 1 by 1 minus x. So your s is 1 by 1 minus x whole square. And this is 1. Hope you got how we got this. So 1 plus x square, this is an infinite GP. So a by 1 minus r is basically the sum of infinite GP. So your a, or the first term, is 1. 1 minus r of the common ratio here is also x. So this is what we got from here. Okay, hope this is helpful. Please drop a note if you are not clear, but the idea here is we will use the multiplication with x and try to make it an AP or an GP if it is an AGP. Okay. Moving on, find the sum of 1 plus 4 by 6 plus 9 by 36. Okay. 1 plus 4 by 6 plus 9 by 36. Okay. So what we should do here, just a minute. Yeah. So what it says the sum is 1 plus 4 by 6. So again, your S is equal to 1 plus 4 by 6, 9 by 36. Like that. So you can see top we have 1 square, 2 square, 3 square, right? And 4 square. And the bottom is basically 6 to the power 0, 6 to the power 1, 6 to the power 2, 6 to the power 3, right? So I can say until infinite, right? So till infinite. Now what we need to see typically here is how they are working. Okay. So what we can do here is kind of a similar problem. If we see this problem, so it was what? X squared, x cubed, and something like this. Now here, if you see in this problem, what we have to do? So can I assume, say, x is equal to 1 by 6. So can I write this set, which is s equal to 1 plus 4x plus 9x square plus 16x cube and so on till infinite. Okay. So what I did x as 1 by 6 because bottom one is the power of the same value, power of this different powers of the same value, that is 1 by 6. So 1 by 6, first one is 1 by 6 to the power 0, second one is 1 by 6 to the power 1. If I'm considering only the numerator, sorry, denominator, say third value is 1 by 6 square, fourth value is 1 by 6 cube, and it continues, right? So I know s the same way. Now let's multiply with sx and start writing it after first term because there are infinite terms now. So the first value will be x, multiplying 1 with x. Second, 4x into x will be 4x square. Third one will be 9x cube plus so on, right? So what did we get? So we get s minus sx is first term is 1, second term is 3x, first term is 5x square, right? Now the next term is 7x cube, and so on. Now, if you see carefully, now we actually got an AGP. Now we actually got an AGP. Your first 1, 3, 5, 7, these are in AP. X square, x cube are in GP. Previously, it was not in AGP. 1 plus 4x. So 1 and 4, there is a gap of 3. 4 and 9, there is a gap of 5. 9 and 16, there is a gap of 7. So this is not in AGP. Though the x square, x cube were in GP, but the coefficients were not in AP. Now they are in AP. So the idea here is I will do the same exercise again. So I will again multiply with x the whole term. Okay. X into s minus x. Now I will write it again. So x, 1 into x is x plus 3x square plus 5x cubed. Okay. So what I'll get from here, I'll get x sx out and put 1 minus x here. So just taking s common. Right? Or let me rewrite. Or can I say s minus sx into 1 minus x? So this is what I'll get if I subtract this from this. So s minus sx is common in both the places and 1 minus x. So this is equal to 1 plus 2x plus 2x square plus 2x cubed plus so on. So here, what do you think will be my r, or how we can write this? So this is what we want to see. Okay. Okay, there was some challenge in the net. So if we see carefully, what we need to do is the right hand side, it has to be a particular form. Okay. Now, if I see this is, okay, let me just replace this a little. Yeah. So if you see carefully, this is 1 plus if I take 2 common, this is x, or I'll take 2x common. So that means this is 1 plus x plus x squared till infinite, right? Now, from the right hand side, if I take s common, this is 1 minus x, 1 minus x. So can I write s into 1 minus x whole square is equal to 1 plus 2x into 1 by 1 minus x. The same thing we did earlier. This is basically does 1 by 1 minus x. Okay. Now, so my final value will be s is equal to 1 plus 2x by 1 minus x whole divided by 1 minus x whole square. Right? That's the final value of x. Okay. So what we did, this is a little complex from the previous one where we need to multiply with x and divide or subtract two times. Previously we did one time. This is the thing we need to do two times. So we are trying to show all the different type of problem that can come in your if AGP has to be complicated or a progression problem needs to be complicated, how it will come. So unless you actually come up with an AGP, or AGP here is at this stage. At this stage, we got the AGP. So we have to first multiply with X and then make it an AGP. If it is already AGP, you have to multiply and subtract once. Multiply with X and subtract once. But if it is not already in AGP, you have to first bring it back to AGP. And then from there, we should do. By AGP, I mean arithmetic geometric progression. So your coefficients, if you see this line, if you see this line typically, your coefficients of 1, 3, 5 are in AP. Your variables x, x square, x cube are in GP. Okay, so that's what it's called AGP. Please drop a note if some part of this is not clear. You want more clarity on something, we'll be able to guide you. Please drop in a description box. Okay, the next problem, 8 plus 88 plus 888 in the nth term. Okay, so this is a little different. Is 8 plus 88 plus 888 plus n terms till n terms. Okay, now there is no common way of doing this. There is no one fine way of doing this. So what we can do is so if we take 8 out or 8 common, right? So this will become 1 plus 11 plus 111, right? 111. Now, and that will continue till n terms. So can I say, so 1, 1, 1, 1, 1, 1, none of these are in AP or in GP. So I have to so divide by 9. So you will get 9 plus 99 plus 999 till your Tn, right? Till your Tn. So this can be written as 8 by 9. Now, if I know 9, the moment I know 9, I can write it as 10 minus 1 for 9. For 99, I can write it as 10 squared minus 1. For 999, I can write it as 10 cube minus 1. So can you see a pattern now? For Tn, I will be writing it as 10 to the power n minus 1. Now, I hope you got the pattern. So this comes with a little practice. If you're given just a number, you have to go somewhere by using 9, and then that's the pattern that you can break into 10 and 1. So where 1 is becoming constant for every term, 10 is basically getting exponentially increased to satisfy that term. So for 9, it will be 10 minus 1. For 99, it will be 10 square minus 1. For 999, it will be 10 cube minus 1, and so on. If I do 8 by 9, then basically one series I got 10 plus 10 square plus 10 cube till 10 to the power n. And then I got n number of ones multiplied with n terms. So that is minus n. So if you take all the ones, that will be n. Okay. Now if you just need to do 8 by 9, and what is the AP 10 plus 10 square plus 10 cube 10 to the power n. So this is an GP with a common ratio of 10. So the formula of Sn is A r to the power n minus 1 by r minus 1. So A is 10. R to the power r is also 10. So r to the power n minus 1 minus 1 by 10 minus 1. On 9, I'll say minus n. Minus n. So this is the final value. right? So this is what is the final value. Okay, so if you have options, you can check which one comes closer, but that's how we need to do. So whenever there is a series of terms like this given, try to get it to at a level of 9 so that you get it in a 10 minus 1 format. So this is another way. So all these I'm trying to do different type of problems so that you get a hang of the overall thing. Okay, let's go to 9. Says okay, 1 plus 2. Okay, now if you see this carefully, this is 1 plus 1 plus 2 plus 1 plus 2 plus 3, 1 plus 2 plus 3 till n. So nth term is till n, second term is till 2, third term is till 3. So that's what the commonality, right? That's what the commonality is talking about. Now, you can see this carefully. What is my Tn? My Tn is 1 plus 2 plus 3 till n. So since there are n number of terms, I'm trying to generalize Tn. My Tn is n into n plus 1 by 2, right? This is my Tn. So that means I can say this is n square by 2 plus n by 2, right? So that means what is my T1? My T1 should be 1 square by 2 plus 1 by 2, which is 1. That's what we have. What should be my T2? My T2 should be 2 square by 2 plus 2 by 2. So this first part is 2, second part is 1. So that is 3. If you see this value is 3. What is the third value? This is 6. Let's see if we get 6. So T3 as part of this 3 square by 2 plus 3 by 2. 3 square by 2 is 9 by 2, or we can say 4.5 plus 1.5. So that is 6. So what I can see here is first, since there is a n number of terms and then there is a pattern how first, second, third, and nth term is evolving, I will generalize the nth term. And the generalization of the by calculating the nth term is n square by 2 plus n by 2. Now I will replace n for the term that I'm trying to get the value, and I will get the value for that particular term. So T1, I put n as 1, I get 1. T2, I put 2 and I get 3. And that's exactly matching what is given. So this is a generic approach. So can I say my Sn, which is nothing but T1 plus T2 plus T3 till Tn, right? What is my T1? My T1 will have 1 square by 2. So if I take all the square terms first, then T1 will have 1 square by 2, T2 will have 2 square by 2, T3 will have 3 square by 2 till n square by 2. And then I will take the first terms. That's the second terms. So then I will have 1 by 2 plus 2 by 2 plus 3 by 2 plus n by 2. So this is what I will have. Okay. Use this for the, yeah. So then, just a minute. Yeah. So then what we have, just put it in the side. Yeah. Hope this is visible. So then what we'll have, so if this is visible, so let's see what we have. So in the first term from here, I can take 1 by 2 common. So that means it will remain 1 square plus 2 square plus 3 square dot n square. From the second sum, if I take 1 by 2 common, it will be 1 plus 2 plus 3 dot n. So if it is a square, we know the formula of this. The formula of this is n into n plus 1 into 2n plus 1 by 6. And formula for this is n into n plus 1 by 2. So now you got the answer. So this is going to be, sorry. So this is going to be your answer. Okay. So what we did, we generalized Tn, and from Tn, we try to reproduce T1, T2, T3 by replacing the value of n with the right term for which we are trying to figure out. So if it's T3, we will put n equal to 3. But this is my most generic of Tn, and this is going to be my base for everything. Okay. And then from there, since we got a sequence and we tried to we got the way we should reproduce T1, T2, T3 so that it matches with what it's given. And also we get a pattern in T1, T2, T3 till Tn. And that pattern we use to solve the problem. Okay. Into the next problem now. Also, if you see, this is a little different type of problem because the first term has n terms, second term does not have the first term. Third term will not have the first and second term, right? So can I say, so if you see, what is T1? T1 is 1 plus 2 plus 3. So T1 has everything. What is T2? T2 does not have 1, 2 plus 3 till n. What is T3? T3 does not have 1 and 2. So 3 plus 4 till n. Similarly, continues, right? So can I say for some, I have one once, right? I have one only once. I have two twice. I have two twice. So 1 plus 2 square. Right? Then I have 3 thrice. So 3 cube. Then I have 4. Then I have 4 times. So 4 to the power 4. Then I have n number of times. So n to the power n. Okay, just a minute, not the right way. So can you see what we did wrong? What we did 1, we did 2 square because 2 is twice. Now 3 thrice is not 3 cube. So this is a very important understanding. So this, what I should have written is as, so this part is wrong. Why I will tell you. So is actually 1 once, 2 twice, 3 thrice. So that means 3 gets added thrice, not 3 get multiplied thrice. So can I say this is 3 plus 3 plus 3? For 4 will get 4 times 4 plus 4 plus 4 plus 4, right? So what is happening typically is 1 plus 2 square. 2 square because 2 gets multiplied twice or 2 gets added twice, same. But 3 gets added thrice versus 3 get multiplied thrice, both are two different statements. So in the first one, we actually did 3 multiplied thrice, but 3 is not multiplied because we are doing T1 plus T2 plus T3. So 3 should be added thrice. So that is 3 square. Okay. 4 gets multiplied 4 times, so that is 4 square. Similarly, 5 square and so on. So this is nothing but n into n plus 1 into 2n plus 1 by 6. Right? That's what we have to do. So instead of writing 1 square, 2 square, 3 square, 4 square, they will complicate the problem and give it to like this. So you have to identify this. 1 gets added once, 2 gets added 2, so that means 2 square. 3 gets added 3 times, so that is 3 square. 4 gets added 4 times, so that is 4 square. Okay. First, you need to understand this. 1 is using ones, 2 is using only in the first and second term, 3 is only in the first, second, and third term. Similarly, 4 will be only in the first, second, third, and fourth term. N is the only term that is present in every term. Right? That's what they're doing. So a simple, very simple problem, but presented differently to you, you may get confused. Let's move to the next problem. It says find sum of 2 square plus 2 into 3 square plus 3 into 4 square plus 4 into 5 square. So this may look little daunting to you, but still there is a approach to it and we will follow. Okay. So if you see typically what is the trend you can what if you see the first term or t1, can I write it as 1 into 2 square? T2, what I can write? 2 into 3 square. T3, what I can write? 3 into 4 square. So you see there is a pattern. So can I say my Tn is nothing but n into n plus 1 whole square? N into n plus 1 whole square, right? So if I have to break it down, so this is n into n square plus 2n plus 1. That means I can say my Tn is 2n square plus 1, n cube plus 2n square plus 1. Now, if with this formula I put T1 should be 1 cube plus 2 into 1 square plus 1. So that means this is 1 plus 2 plus 1, that is 4. And that's what my T1 is. This is 4. What is my T2? 2 into 3 square, 9 into 2, 18. Let me see if I get T2 as 18 with this generic formula. So T2 will be 2 cube plus 2 into 2 square plus 1. 2 cube is 8. 2 into 2 square is 4 into 2, 8. 8 plus 8, 16. Just a minute. Cube. It should be 9 into 2, 18. So we got 8 plus 8, 16 plus 1, 17. Okay, just a minute. Let me see if there is anything we have missed. N square plus 2n plus 1. Okay, the final value should be n. That's what we missed. N, if you multiply it, n cube plus 2n square plus n. So that means this final value will be 2. So 8 plus 8 plus 2, 18. Similarly, let's see for T3. What is T3? T3 is 3 into 4 square. 4 square is 16. 16 into 3, 48. Let's see if I get 48. 3 cube plus 2 into 3 square plus 3. So this is 27 plus 18 plus 3. We get 48. So we can safely say my Tn as this is a generic term. Now using this, I'll just read it. Yes. Okay. Now using this, can I solve the problem? Because I have to go till T10. Okay. So my Sn or S10, I will say, because 10th term is where I need to go. The first one is 1 cube, 2 cube, till 10 cube. The second term, if I take 2 common, it will be 1 square, 2 square, till 10 square. And the third term will be just 1 plus 2 plus 3 dot 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 n. Right? Because first term will be cube, second term will be squared, third term will be power to the power 1. So the first term will be, we know till n cube, it's n into n plus 1 by 2 whole square. So what I'm trying to say is 1 cube plus 2 cube plus 3 cube till n cube. The value is n into n plus 1 by 2 whole square. So from here we can write this is 10 into 11 n into n plus 1 by 2 whole square. Next one is n into n plus 1. So n into n plus 1 into 2n plus 1. 2n plus 1 is 2 into 10 plus 1. So 21 by 6. And last one is n into n plus 1 by 2. You can solve it and get the answer. So what you need to know till the cube happens. So you just need to know the formulas of 1 cube, 2 cube, 3 cube, till n cube. It's n into n plus 1 by 2 whole square. Now you also know the squares ka formula. 3 square till n square. It will be n into n plus 1 into 2n plus 1 by 6. And we are just replacing the 10 with this. So this is your answer. Okay. So again, the idea is generalize the nth term, or in this case, the 10th term, and from there try to get a generic, rewrite the expression, rewrite the terms in such a way so that they form an AP, or part of them together form an AP, the second part of them together form another AP or GP, whatever it is, so that they can become arithmetic or geometric progression. The term, so see, the idea is I can give you 4 as a number, I can give you 4 as a 2 square, I can give you 4 as the way we did 1 cube plus 2 into 1 square plus 1. Depends on your problem how you can generalize a particular expression. So, and then with that generalized expression, can you reproduce all the terms, the value of all the terms? So the we generalize the Tn, n cube plus 2n squared plus n. Now we are trying to reproduce all the terms by replacing n for that term. So first term will replace n with 1, second term will replace n with 2, third term will replace n with 3. So if we replace n with all that, can I get the same value of the first, second, and third term that is given in the problem? If I get it, that's perfectly fine. And with this, I will be able to create a series of APs together. Okay. See what is the next problem talks about. So it says second term of a GP is 1000. The common ratio is 1 by n. So second term of the GP is 1000 and the common ratio is okay. So you see second term, don't get confused by so many, don't get overwhelmed by the complexity of the words in the problems. See, it's simple. Second term of a GP is 1000. So simple, can I say T2 is 1000? The common ratio is 1 by n. The common ratio is 1 by n, where n is a natural number. Pn is the product of n terms in GP. If n is a natural number, your 1 by n will always be a positive number. If n is a natural number, what is a natural number? 1 onwards is a natural number. So 1, 2, 3, these are natural numbers. So if n is a natural number, your 1 by n, n 1 by n will always be a positive number, because 1 by 1, 1 by 2, 1 by 3, whatever it is. Now n is a natural number. Pn is the product of n terms of this GP. So P6 is greater than P5. So what is P6? P6 is T1 into T2 into T3, T4, T5, T6. And what is P5? P5 is T1, T2, T3, T4, T5, right? P6 greater than P5. P6 greater than P5 is P6 greater than P5. P6 has all the terms and P5. So can I say my T6 is greater than 1? My term 6 is greater than 1 because T1, T2, T3, T4, T5, T6 is greater than T1, T2, T3, T4, T5. So T6 is the only term that has to be greater than 1. Otherwise, P6 will not be more than P5. P5 have all the 5 terms, right? So then, uh, what is similarly, what is P6 greater than P7, they said. Now, what is P7? P7, let me write it this way. P7 is what? P6 into term 7. So here I can say 1 greater than term 7, or I can say term 7 is less than 1. So term 6 is more than 1. Term 7 is less than 1, right? Think of this. Term 6 is more than 1. Term 7 is less than 1, right? So, to see. So if my term 6 is, if my T2 is 1000, okay? If my T2 is 1000, what will be my T3? My T3 will be 1000 into 1 by n. What will be my T4? T4 will be 1000 into 1 by n square, 1000 into 1 by n square, multiplying 1 by n twice. What will be my T5? My T5 will be 1000 into 1 by n cube. My T6 will be 1000 divided by n4, and T7 is 1000 divided by n5, right? Okay. So what I got finally, I reduce this part. So what I got finally, I got my T6 is 1000 divided by n4, and my T7 is 1000 divided by n5, right? So can I say, just a minute, shorten this further. So can I say my 1000 divided by n to the power 4 is greater than 1? So can I say 1000 is greater than n to the power 4? Or I will say n to the power 4 is less than 1000. Sorry. N to the power 4 is less than 1000, right? Similarly, on the other hand, I'll be able to say T7 is less than 1. T7 is less than 1 means I'll be able to say 1000 by n to the power 5 is less than 1. So that means I can say n to the power 5 is greater than 1000. So basically what I'm zeroing on then, n to the power 4 less than 1000 less than n to the power 5, right? N to the power 4 less than 1000 less than n to the power 5. Now, if you think typically, what is 5? What values n can take that satisfies this condition? See, 5 to the power 4 is 625. 5 to the power 5 is more than 1000. So n can take 5. Can n take 6? See, 4 I will not be able to take because, or 4 also we can take. 4 to the power 4 is what? 256. 4 to the power 5, or 2 to the power 10. 4 to the power 5 is 1024. So n can also take 4. Can n take 3? 3 to the power 4 is 81. 3 to the power 5 is 243. So n cannot take 3 because 3 to the power 5 is not more than 1000. N can take 4. N can take 5. Can n take 6? 6 cube is 216, and 6 to the power 4 is more than 1000. 6 to the power 4 is more than 1000 because 6 cube is 216. If you multiply 216 with 6, it will be more than 1000. So n to the power 4 less than 1000 will not satisfy. So n can be only 4 and 5. So the answer is n equal to 9, because this is sum of all possible values of n. Sum of all possible values of n is 9. Okay. So now we got this. So this is a good problem where we find out in a different way how we can solve it. So these are the different type of problems you can encounter in terms of AP and GP. But still, if you have doubt, you can drop a note. We'll be able to solve some of your doubts easily, or over a mail or over a quick call. Drop me a mail if you need more help. But the idea is do at least 3x number of problems. We solved today around 10, 11 problems. The idea here is you will try and solve at least 25 to 30 problems of this type, and the 25 to 30 problems on the previous sessions type. So around 50, 60 problems of APGP, you will be mastering this completely. Okay. So hope this is helpful. Please like, share, subscribe if you find out this complete free CAT training useful and it is helping you in some way. Share with your friends and spread the knowledge and spread the word, and that will be a good motivation for me to keep creating such videos. See you next time. And then thank you for joining. Bye.